Hello, nice to be here. I haven't been to UKNOF before. It seems very good. I know some people here. I've known you while I was working at ICANN. I worked at ICANN for a number of years. I left eventually for time off for good behavior, I think. And so I'm now at Dyn. And some of you may not have heard of Dyn. Dyn is an internet performance company. That's a marketing phrase that doesn't mean much to me. We do DNS mainly. And we do DNS for things you probably have heard of, like Twitter and eBay and other things that your customers certainly rely upon. And our business is trying to make sure these things stay up. So what we've noticed with these particular kinds of customers is that it's really quite essential to be up. We have a user base, all of us, of users who are increasingly non-technical. They are people who expect things to work, and if they don't work, there's really no way that these people can troubleshoot. My wife will tell me in the morning, Facebook's a bit flaky today, and earlier on in our marriage, I might have started to say, well, perhaps we should check the gateway, or perhaps the cable has a bit of loss, or perhaps something else is going on. But I've learned now just to say, yeah, that's right. So what are the implications for this? If you're running a service, I mean, these days, everything that you do online is, everything that you try and do tends to touch something online. If you're a grandmother looking up your family tree, you're probably using something online. You're sending email. You've got thermostats and light switches now, and smoke alarms and things like that all depend on the internet. You don't know the internet is there. I mean, I have children now who, if you try and explain to them a concept of a computer that wasn't connected to the internet, their immediate thing is, well, what's the internet? I've never heard of that because it's just something that seems to be part of the computer. It's part of the screen. I went and talked to my 6-year-old school class about the internet, and I managed to keep them entertained with pictures of cats on a regular basis. And you ask them, where do you think the information comes from and things like that, and they all say things like, oh, it goes through the screen. Because in their minds, this is what happens. Behind the screen is this thing that things appear on. Nobody has any concept of what the internet is in the real world. So consequently, if something breaks, who do you call? And the answer quite often is there is nobody to call. The average person has no idea. You might have a service that you pay for, in which case there might be a help desk you can call. But by and large, if it doesn't work, and it doesn't work often enough, you just stop using it. So this is the death to any sort of startup company. So if you're a big established player and you've been around for a while, you have the money and the resources to be able to build infrastructure all over the place. You build giant data centers and you put them in multiple geographic regions and you choose your peers and your transit providers carefully. And you can do all this stuff. And if you're a startup company and you're trying to build some application that's targeted towards the naive user, you either have enormous startup costs or you build on someone else's infrastructure, which is the more likely thing to do. So years ago, the question was, should you go to a data center or should you build your own data center? That's no longer really the question that anybody has. Now it's more like, you buy your own servers, or do you just buy server capacity somewhere else? Do you build all this stuff into the cloud? Do you migrate this stuff around in these elastic regions? And at the bottom of all this, specific to Dyn, is the idea of the DNS being outsourced. The DNS has been overlooked by a lot of people for a long time. It's just one sort of thing, you set it up and it works. It was a fairly trivial thing for us, a junior person, to set up, and you never worry about it again. But things have changed a little bit. It turns out that problems in the DNS cause problems for everything. And when you're in a situation where everything needs to be up all the time, having DNS that's quite functional is quite important. Not just in terms of availability anymore, but also in terms of performance. You might think that the round-trip time to an authority server in the DNS is, a problem that you largely don't have because you rely on things being cached. But it turns out that it actually can make quite a difference to your revenue, having DNS that resolves quickly and reliably compared to DNS that doesn't. So this is a presentation that's really quite a speculative thing, and I'm really more here after information from you guys than I am trying to give information in this direction. So I'll try and cut the actual speaking low so we can get some time for talking. And if there are no questions and I've failed in an abject manner, then at least we can move on quickly to the next one and be closer to beer. So I think we win either way. So, DNS. Characteristics of the DNS as a protocol are that it is mainly stateless. Most DNS traffic is carried on UDP. UDP, as we know, doesn't require any state to be kept. There's no setup handshake. There's no teardown handshake. It's mainly UDP. I mean, obviously DNS can be carried on TCP as well, and there is work, speculative work going on in various venues with the idea that perhaps TCP is a better transport for the DNS because you can't spoof it so well. and spoofed DNS queries and reflection attacks become a headache for every network operator, so there's a certain amount of traction in that idea. But largely, Anycast almost seems like it was designed especially for the DNS or vice versa. Anycast works very well with the DNS. Even the amount of TCP traffic that there is tends to be short-lived, and it turns out that transactions in the DNS over TCP are brief enough that the network tends to be stable for long enough that you don't oscillate between Anycast nodes. I presume here I'm talking to an audience that knows what Anycast is. There are nods, that seems good. So how much Anycast is enough? A lot of people started doing Anycast in the DNS, and they perhaps would have 2 nodes. And the reason they had Anycast happening at all was not because of reliability or performance. It was simply for ease of maintenance. Being able to just take a node down in the middle of the day and fiddle with it and then bring it back up again without anybody noticing is a good thing. You don't have to worry about maintenance windows anymore. You can just do the work when it occurs to you. Since then, any people have Anycasted for different reasons. And the example here is taken from rootservers.org, which is a quite crude and nasty web page designed by people with beards. There's a particular kind of beard I'm talking about. You know what I'm talking about. And so here's an example. There's a map of the world. It's got lots of nice pins in it. And we have some examples here. There are 13 root servers, A through M. And I picked out a couple of them that tend to be Anycast fairly widely. F, run by ISC, 56 nodes. I, run by Autonomica in Stockholm, is 43. While I was at ICANN, we did a bit of a push on LRoot, and we deployed 146 locations for that. So there are some examples of here, reasonably widespread Anycast. And the question really is, how much is enough? How much do you want? If you're going to go ahead and think, bugger it, I'm just going to do as much Anycast as I can, how much would you aim to do? Which is a reasonable question to start with. Once you've passed a certain threshold, managing 200 nodes is pretty much the same amount of effort as managing 500. And if you can do 500, you may as well do 1,000. And if you can do 5,000, you may as well go a bit higher. So what's the limit? Where do we head? Where's the ceiling? So our thinking led us to this kind of graph here. So there are about 50,000 ASs that advertise at least one route on the internet. There are more or fewer depending where you look from, but there's around 50,000. There's more that have been allocated, but there's 50,000 actually in use, or just a little under. And it continues to grow in this nice straight line. So we thought, well, if we're going to pick a number for how many nodes we should have in an Anycast network, let's say, one or more in every AS. Let's make sure we can scale to that. So now we're talking about a 50,000 node Anycast network. So now the number is nice and big. The number is big enough that we have to really make sure that every kind of difficulty we might experience in operationally in managing these things and in paying for the location of all these nodes, we need good answers for this stuff. Otherwise, this is impractical. So this has set the stage for the kind of thing that we're thinking of doing at Dyn. We've got 20 or so nodes right now, which are conventional builds in data centers with racks and servers and things like that. If we're going to do 50,000 nodes, how are we going to do that? So the goal here is really to try and keep the DNS service as close to the end user as possible. And part of this is for performance reasons. It's so that when the user types in twitter.com, they get a reliably close answer, and any vagary that might happen in the network, even if we expect to be able to jump 3 or 4 ASs in the UK and have pretty good performance, that's not so much the case if you're in Uganda or in Tanzania or in one of the other sort of dark cobwebby parts of the internet. So keeping this stuff local seems like it makes a lot of sense. We minimize the round trip time between the server and the client. And so already we're starting to think we need something that's easy to host. We need a box that's cheap. We're going to have loads and loads of capacity. We get more capacity in a 1U sort of Atom-powered box multiplied by 50,000 than we do in the data centers we have right now. So this is leading us down a path that's thinking, okay, well, now we're thinking about an appliance. We're thinking about a 1U appliance that would be something that we could rack into an ISP, into a 2-post relay rack, and it would sit there and make the lives better for customers and hopefully for the ISPs as well. So let's continue thinking down this road. So we have an aim to deploy 50,000 nodes. We don't especially want to be able to have to hire 50,000 people to look after them. So we need all the stuff to be very much hands-off running itself, which means the interactions that we might expect to have with the ISPs that hosted them need to be very lightweight. And as an ISP, we imagine we don't want people at ISPs to have to think, I'm going to have to renumber that server, so I'm going to have to send an email and open a ticket. and wait for time zones to tick around so somebody answers the ticket, and then they're going to say, well, is this time good for you? And they're going to say, well, that's okay. And then the time changes, then they have to get back to you, and suddenly a week has gone by and you still haven't even planned the time when you want to move this thing. So let's eliminate all of that. Let's make it all self-service. Let's give people access to the configuration of the box that's already there in the network. It's their appliance. Let them run it according to how they want to do it. Let's not add an extra dependency to the operational workload of the ISP. When we ship these nodes out, let's ship them directly from the factory. We don't want to have to deal with the box ourselves, which leads us down to say, well, how should we install the stuff on this? We're running our own code. How would that be installed? Let's make that as simple as possible as well. Let's make recovering from a failed box as simple as turn it off and on again. And if you do that and it can get on net, perhaps it'll reinstall itself over the network. If it's really, really broken, perhaps you have to reinstall, stick a flash disk in the front, which with the image that you downloaded from the web page where you configured your sessions and things. And if it's really broken, really just take it out of the rack and throw it away, and we'll send you a new one. These things are small enough that we can probably get away with making the support burden on the ISP as light as that. As I said, low-power appliance, suitable for mounting in a 2-post rack. Maybe we even do an appliance with DC power. Maybe for some people that makes it easier to install. So we're trying to make it as easy as possible and for an ISP to stick this in a rack and just have things become magically better and not have to worry about it. It shouldn't be the kind of box where you have to visit and call and send emails and open tickets. So security considerations. If we have 50,000 nodes, and all of them are deployed in places which are not our data centers, then we have a potential security risk here. We have 50,000 boxes deployed directly into hostile networks from our perspective, not from yours. And we have to be able to manage these things and ensure that they're actually working properly. There's a fine line here. There is no absolute security. We know that anybody who wants to hijack an address and sort of pretend to be a DNS server for twitter.com can do it anyway. We can't solve all those problems ourselves, but we can try and bring the path between the end user or between the recursive server and the DNS server down to the absolute minimum so that the opportunities for doing that kind of a deception are reduced. We don't have any secrets on the box. We assume that anybody who's interested could pull this out of the rack, rip its hard disk out, plug it into a Linux box, mount the file systems, and have a look. That should be fine. And if somebody does that, they shouldn't discover any secrets that are useful for interacting with any other node. They're really all specific to this node. And the other thing we like to think of is if our installation is as simple as we hope it will be, then why not do what our friends at Netflix have done, which is to randomly cause damage in the network just to make sure that they can handle it. So, we have boxes, perhaps we'll have boxes that will automatically reinstall themselves from the bare metal once every couple of weeks, just to make sure we can still do it. Reinstall monkey, what was my idea for that? It's not a very good name. So one thing that Dyn's already very good at, which makes this a nice fit for this kind of infrastructure, is automated configuration management of more or less everything. In previous lives, I've been places where Puppet was the thing. At Dyn, the religion is Chef, but it's all the same sort of idea. Every change that gets pushed out through test environments and regression testing and all the rest of it is completely automatically controlled. There's no manual configuration of anything on these boxes. Nobody should ever need to SSH to these boxes, but more to the point, nobody should ever want to. The goal usually with making these things work is to make it easier and less of a hassle to do it through the configuration management tool than it is to go in and do it directly. And if you have 50,000 nodes deployed, then that's pretty much a given. Nobody wants to SSH into 50,000 nodes and change something. Same thing with element monitoring. The NOC is, I think, not yet aware of the implications of managing 50,000 boxes across the world, of which probably 20% are down or have some kind of problem at any time. They're going to find out at some point soon. But we need to have some sort of automatic way of monitoring this stuff that doesn't require humans. We want boxes to be coming and going every day. The monitoring of these things should be automatic. And again, this ties into the infrastructure we already have at Dyn for managing infrastructure with Chef. So we expect to have nodes in parts of the map that the root servers map earlier really were empty. Africa has got hardly any nodes in. Southeast Asia doesn't have many outside the obvious places. We expect to have nodes everywhere. So we expect to be in parts of the internet which really don't work very well. There's pervasive congestion and packet loss and all the horror stories that you might remember from the UK, I don't know, sort of mid-90s perhaps, are the reality today in a lot of places. There are places where the entire IGP consists of a group of people who have telnet access to their routers and like type static routes all day. But there's no actual dynamic routing going on whatsoever. A link fails, someone has to telnet or drive across town with a laptop and plug into a serial port and change a static route. I mean, this happens still today. These are the kinds of environments that we're going to go into. So we need to be very light on the network, and in particular, our assumptions need to be that the network's broken. We probably can't reach every box in real time, even though it's still providing good local service. If we want to pull data back from these things, if we want to take packet captures and to isolate some sort of particular DNS attack that's going on, we can't expect to centralize all that stuff. It's not going to work anymore. We can do that with 20 locations in well-developed networks. We can't do that with boxes and all the crazy ISPs in the world. So we have to have a different way of doing it. And if we have enough boxes, we also know that just because the transit seems to be down for the box in Nairobi doesn't necessarily mean that the box in Nairobi can't talk to the box in Dar es Salaam, because there are peering exchanges in common. So perhaps we can employ a swarm type peer-to-peer approach so that we can flood provisioning data out to all these nodes into a giant BitTorrent-like swarm and have analytics and things and summaries of measurement that's happened out on the edge to be pulled back centrally so that in somewhat real time we can have an active view of what the network is doing. So we'd never tried to do anything on this scale before, so we're guessing, and some of these guesses are going to be wrong, but these are the kinds of approaches we're looking at. So at the end, what we hope to build is something that is enormous DNS network on the scale of which I haven't seen before. I mean, there are some Anycast and some CDNs which provide DNS services for their customers, and they have many nodes. We have existing examples of infrastructure deployed into ISPs by Google and Akamai and things like that. So this is not brand new thinking of this kind of deployment, but we haven't seen it done with a DNS before. And what we expect to get out of this, as well as just improved performance and better for the end user and for the people who are our customers, is an idea of being able to view the network from a vastly larger number of perspectives than we've been able to do before. So that means we have, potentially 50,000 views of the routing system. We have 50,000 views of the clients that are talking to these DNS servers. It means suddenly we have an opportunity to say, well, this particular client address, we routinely see traffic for them in Manchester. We don't normally see traffic from them in Sao Paulo. So perhaps if we do see a packet down in Sao Paulo that's apparently from this address, perhaps that means something. Perhaps we can build reputation for stateless services in the DNS. And perhaps we can do something, finally, about the problems of spoof sources and reflection attacks without having to wait for the holy grail of BCP38 to be deployed anywhere, never mind everywhere. So that the reason I'm here, and we have 5 minutes left for questions, which is not a lot, but hopefully for a couple of questions, is this whole model here depends on there being value in both directions. The value for us and for the Dyn marketing team of being able to go out and say we have a bigger platform than everybody else, I mean, that seems fairly clear, that's easy. And in fact, we're already doing this, so we don't need to convince ourselves to do it. But the part here, which is the missing part of the puzzle, is to try and work out what is the value that we can give to the ISP to make it worthwhile for the ISP to put this appliance in their rack. So, for example, we can give you a route views type service, which is based on 50,000 views of the table, or however many nodes we have deployed. But I'll use the word 50,000 because it's a big, impressive word. We can tell you what your customers are doing with particular name servers. We can show you trends for how many of your customers are using Twitter or something else, or at least doing those lookups. Perhaps we can, in some cases, even with authority servers, we can fingerprint particular infections that your customers might have. We can tell you that this particular address within this period was doing lookups that suggest it might be infected with worm X. Maybe we can feed that to you in some sort of automatic way. Maybe a help desk then has the opportunity to say when the customer calls up, tell this customer they're infected with this, or at least bear that in mind as you talk to them. I mean, obviously the core reason for deploying any of this stuff is faster and more reliable DNS service, which we hope is good for customers. But that's kind of a nebulous thing to be able to say to an ISP, host our box, because it'll make things better, trust us. And we think perhaps we need better answers than that. We could deploy recursive servers as a container on these appliances. If people have continual problems keeping their recursive servers running, perhaps that's of value. Perhaps having a recursive server, which is, if it's down in your network, but it's up in your peer's network, and all the ACLs are open to be able to understand where the client should be coming from, maybe that's more reliable than you can build yourself in one AS. And perhaps we can give some ability to make other use of this massive footprint and say, let's measure your stuff from all over the place. And if you care about things being up, perhaps we can give you off-net notifications of things being down. There's lots of ideas. And finally, maybe we can just host DNS for you. If hosting your DNS for your customers is a pain, perhaps we can do it. And perhaps that's a way that we can help each other and build a partnership that actually works. So that's the last slide. And what I'm hoping is that there's at least a couple of people in the audience here who have an opinion and can answer the question, if these kinds of appliances existed and they did the kinds of things that I've described, what is the kind of benefit to you as an ISP that would lead you to host one of these things underneath a router in a pub somewhere? Anybody?
Hi, Dave Reeder from Zen. Interesting presentation. I had a number of thoughts while you were talking about that. I think first off, and you sort of touched on this with your question, I think the big thing here is the claim that we need 50,000 DNS servers. I wonder where the evidence is that says that DNS round-trip time makes that much difference, because even today we see the very biggest most profitable businesses on the internet aren't deploying their DNS to that extent. So they don't perceive there to be a payback for doing it. So I wonder where that comes from. But the other thing linked to that question, when you get to this, well, there's 50,000 ASs, I'd turn that same question but round the other way. Why does it need to be that many? Why do you not get the benefit by putting these boxes out to, say, every internet exchange point, where the box can serve multiple ASs and still be almost as good as being on net? Because that then changes it. You're talking about putting very small, low-powered boxes in, but I wonder, don't making them smaller make them more susceptible to local attacks? And what happens then when someone takes out the box in that's serving one service provider? Does that mean that one service provider then doesn't have visibility of your customers? So I think there's a lot of things. Sorry, I've got quite a long list here of things, and maybe I should talk to you after.
Oh, that sounds good. I mean, the quick answer, I think, is just to take those two, because we only have a couple of minutes, is I think you kind of answered our thoughts with the first question with the second one. So in steady state, if everything's working normally, then you're right. Things should be cached for long periods of time, blah, blah, blah. The impact of an RTT once every couple of days to an authority server shouldn't make that much difference. However, we know that a lot of people, for various reasons, are putting 1-second TTLs on the DNS records because they're very dynamic sites and all the rest of it. So in fact, the effect of caching for some of these more popular sites is disappearing. And the other thing we know, and I'm sure everybody here knows, is that there's a ridiculous amount of 4 a.m. headaches that are occurring because of the DNS, because of reflection attacks, because of source-spoofed reflection attacks that are big enough to be able to take down significant bits of network. And that's a much bigger problem if you have 20 nodes in the world than it is if you have 10,000 or 20,000 or 5,000 or whatever the number is that's not as ludicrous as 50,000. If you localize the traffic down, then your attack flows are all on net. The attack flows between the DNS server on your network and the customer on your network are much easier to diagnose and track. And also the noise floor is much lower, so you have a much better chance of noticing that they're going on than if you have a collection of sort of 100 ISPs all contributing towards a giant problem at 4 a.m. for somebody in one place. And if the node in your network does go down, then your customers are not in the dark, because then you go back to the more traditional sort of thing, which is to route out and cross a peering exchange or to follow a transit provider towards another box somewhere else. But I'd love to see a list.
Hi, Charlie from Fluency. I had a question. Just you say that this service would, well, having a box in your ISP would ultimately make everything better magically. But how are you going to do that if you're not providing that ISP with recursive services for their customers? You mentioned that's a sort of, a possible way that you can add value back to the ISP. But surely this is only really going to benefit the Dyn network, and it's not going to make that ISP's experience any better unless they're doing loads and loads of business with Dyn.
Well, I mean, this is why I'm here, to try and find out what the reverse benefit might be from our perspective, forward benefit from you for having one of these things installed, and to get some ideas about, what is it that you might like. Recursive service, we think, is a fantastic idea, and we would love to be able to do that, and I think, done well, It could solve problems for a lot of ISPs. There's a lot of ISPs that are very, very bad at recursive DNS. They don't have the resources for it, and the performance is bad. And the reality is that if the recursive DNS is having a problem, then suddenly you lose any margin you had for your broadband customer for the next 4 months because they're calling on the phone twice a day, and suddenly everything is going to shit. So we think recursive service is great, but we also think that if we're going to do it, we have to do it really, really well. Because the last thing you want to do is to outsource your recursive service to somebody who's, not doing a good job. So there's a curve there at the end of which we have to be able to be sure that our DNS service is rock solid, and we're not sure that that's the best thing to start with. But there are certainly some things. I mean, I think with recursive service, if the idea was to provide fingerprints for malware infections, you have a much better chance of being able to fingerprint those users quickly if you're offering recursive service. But even with authoritative-only service, there are still some things we can do.
Hi, Neil McRae from BT. Actually, I think you've made the point I was going to make, which is if you look at the utilization of a user of the network, the biggest lag is DNS. Yeah. I mean, it's orders of magnitude bigger than anything else, and anything that reduces that just makes web pages more punchy. And when we have a DNS problem, our help desk lights up like a Christmas tree. So I think a recursive service, absolutely. I think the challenges are, as an operator, I want to control that very closely because it literally is the service we provide in some respects. Yeah. And it's kind of one of those things we say is like a platinum sort of device that if it goes wrong, the world ends. So how your service wrapped that problem up and gave someone confidence is probably the biggest challenge that you're going to have. But yeah. I think a recursive service and improving recursion, why wouldn't we do that?
Okay, one more question from Mark.
Hi, Joe. This is Mark Townsley. I'm from Cisco. I'm also co-chair of the HomeNet working group. I've been wondering what Dine's been up to. You've been hiring lots of really good people. And
they hired me too. So that's good.
So this is good. This is interesting. And I think you're looking for your positioning here to some degree. And of course, security, resiliency, performance are all good things. Right. From the home networking group perspective, we have a lot of ISPs coming in saying, hey, we want to be more involved in DNS services, publishing services, MDNS type things, DNSSD, Bonjour type services within the home, et cetera. And so I see a lot of activity in the working group there coming in from the ISPs. If you could crack that, solve that in a way that makes it easier for users, I think that would be some of the sort of additional capabilities that you might be looking for. However, I want to toss one thing out there. There's something else. Don't get too creative. The idea of having a box in every AS in the world is sort of a dream if you decided to be evil with your company. Don't be evil. I think one of your ways to position yourselves is, we're gonna work on the DNS. We're gonna be separate from maybe someone that might be a little bit more commercial, et cetera, et cetera. So don't look too hard lest you find something that kills your reputation.
No,
so
fair enough. Fair point. Yeah. All right.
Okay.
Thank you very much.
Joe.